So this is a preview of the next episode. And again, we are going to give us 5 problems to talk about. And I'm going to explain problem 1 and 3. Okay? Problem 1 is a very nice problem from Mandelbrot contest a few years ago. We have 4 markers like that. They are placed over there. And each marker have red and a black side. Okay, so at the beginning, R1, R2, R3, R4 are in their position. Okay, those are the red coins at position 1, right? So we can treat these coins as distinct in the sense of if they are originally position 1, is different from the one in position 2. Okay? And every step, you are allowed to do this. You have 2 coins, you can swap their position, and then you also have to turn them around. So that's what I explained. If you have 2 coins, if one is in one stage, one is in another stage, right? You can swap them and then flip both of them around. So they could start with 2 red ones. If you swap them, they got 2 black ones. Or you have 2 black ones, swap them, and then get 2 red ones, right? You can also start with a black and a red and end up with a black and red. But the coins which are distinguishable, they're in different places.
So we keep track of that.
We have to keep track of it. So the question is asking, originally on the contest, they just ask a numerical answer. Find the number of minimum swaps you need to make sure all the coins go back to their original position, but they are all turned from red to black. Okay? But we make this a little bit stronger, is we ask our students to give us a precise reasoning. Why do you need that many moves? So this is my point of view. They cannot only always prepare for Mandelbrot, and then after that they prepare for AMC, or they prepare for AMC, they prepare for AME, and after that they prepare for what? USAMO. All this math, they are part of the math study. Reasoning is important, right? So they cannot just say, oh, I got a number. I don't care about what's my reasoning. You do need to, okay? So that's a very good part we add in. We ask our students to make it clear. If using 8 moves is the minimum, explain to us why 8. Why not 7, why not 6? You cannot just say, oh, I tried all possible moves. It doesn't work. There are too many ways to try. You can't exhaust them, okay? So that's number 1. And I'm also going to explain number 3. Number 3 is also a continuation of our cutting problems. This time I give people a 1/3 square to cut. And I'm pretty sure our viewers can follow what we did in episode 1 and 2 or those 1 or 2 of those cuts, right? But this time the problem changed. I give you, this is the cut. I'm going to turn this square a little bit, okay? I will make things like this. I will definitely have the overlap part stay. And then I also clearly see there's a congruent pair of triangles, so I can move them to the other side. So I already give us, those are the preconditions. These are the 2 pieces. Okay, one is the quadrilateral piece, one is the right triangle piece. Okay, based on this, how do I continue my cuts? Okay, I label that big point over there quite significantly because you should start to think what should be that point first, and then you can continue to make the cuts. Okay, so I've done my stuff. Why don't you guys take over?
Number 2.
Okay, yeah, so I'll explain number 2. Basically, in this problem, there is a moat surrounding a castle, and you need to get to the castle, and you're stuck outside. But you're not alone, you have these 2 planks. One of them is 11 feet long, and one of them is 11 feet 9 inches long.
How wide is the castle?
And the moat is, so it's a rectangular moat.
How wide is the moat?
It's
How wide
12
is
feet.
the castle?
Right?
12 feet.
And it looks like this from the top. So this distance is 12 feet.
So our plank are a little bit shorter,
Yes.
right?
Just slightly shorter.
Just slightly shorter. And the moat is dangerous. There are crocodiles down there, right? So maybe if you fall in there, it's not a good thing.
Yeah.
So Yannick, it's not a good idea to jump in.
I guess not.
You guess not, okay?
Also, if you make it across, you might accidentally bump into the castle.
Right.
So,
Yeah, that sounds.
So what is a good way to make a very safe cross, right?
but one person told me that if these planks are made of wood, then maybe if you might be able to take this 11 feet 9-inch plank and then put it in the water and then soak it, and then it'll become slightly bigger because it'll expand, and then it might be big enough to walk across.
I see.
But
My concern is if that wood is like expand, also could get softer too. Then it's dangerous. You walk on their bone.
right. So the question then would be, how do we get across this moat using the planks that we have without any kind of special soaking or jumping or anything?
Okay, so I'll explain number 4, which is taken from this year's FE4G for mass spectral growth. So we have this equation, which doesn't really look that complicated, and we want to solve for x. So it doesn't look that easy, that hard, but when we scribble that, we get a force field polynomial because this square back to the fourth power n. That would be a little bit nasty. So we might want to think of a way to get around it or simplify the computation.
We give this to our students to practice. They find this quite hard. So I think there's some old algebra tricks that students should know, right? So let's bring this and we will talk about it next time.
Yes, and the last problem we will discuss is this problem which was proposed by China TST on letter C. Yeah, and it's the same type of problems that we discussed in episode number 1. But if you guys, you should be careful, the conditions slightly changed. Because numbers that follow odd numbers should be smaller. Numbers that follow even numbers should be bigger. So you get slightly different condition. And there will be this slight difference that makes this problem a little bit harder. You should think about it. And we will discuss it next time.
Students might think, well, how can they, Olympia problem is just slightly harder than Amy problem number 6. Well, first of all, that could happen. Some of the Amy problems are very tricky, right? And also, I want to say this is, during that year, these 2 exams almost given on the same day. So the people are doing this problem have no prior knowledge of that problem at all. So they do not know that trick about backwards. So that makes it a reasonable problem 1. It's like they have 2 tricks to follow. One is the backward thing that we already discussed in the last episode. And then there's one more complication. Right? So it turned out to be a quite good number 1. Some of the students could not solve. Good.
See you next time.
So yeah, we'll see you next week for the solutions to these problems.